and all.
Good evening,
Am I
sir.
audible to everyone? Am I
Good
audible to
evening, sir.
everyone?
Yes, sir.
Yes, sir.
Is the audio clear?
Yes, sir.
Okay. Just to clarify a few things. So, some work.
Yes,
Sir,
sir.
your voice is not clear.
Hello. Hello, is it audible now?
Yeah, sir.
Okay. Just a minute. So, the question that we had given yesterday was on the find locus of the equation, and another question was to find this one, the equation on the point. Just a minute. So the equation that I gave yesterday, which was the equation that I gave yesterday? If someone unmute the mic and respond.
Sir, your voice isn't clear.
Hello, is it okay now?
No, sir, it's still not clear.
Just a minute.
No, sir, it's fine. Please check at your end.
Is it audible?
Yes, sir, you're audible.
Yeah, sir,
Okay,
you're
okay.
audible now.
Okay, dear students, I had given you an equation yesterday to find the
Yeah, sir.
locus.
Yeah, sir.
So, did you
Yes,
get the
sir.
answer for the equation? No? What was the equation? Did you get the answer for that equation, everybody? When we ask about homework, no answer. My God.
Sir.
Yes.
Hello.
Did you get the
Sir?
answer for the equation? Yes.
Yeah,
Yes,
sir,
you
I
did.
got.
Okay, what is the answer?
Sir, is this a straight line or not?
It's not a straight line, sorry.
Sir, I got a straight line, but
No, you can't get a straight
Parabola.
line. Huh?
Parabola.
Parabola. Which equation you're telling? I had given two equations. I had given one parametric equation and another one Yeah.
Minus x square y minus y is
Third order.
equals to 0.
That equation, Vignesh answer is correct. Straight line.
Okay, sir.
I had given another one parametric equation I had given. I told
Sir,
you to find the. I had given you one parametric equation. Yes or no?
Yes, sir.
What is the answer for the parametric equation?
I think
No thinking here. Only accurate answers we need.
because I'm not telling the answer, but I didn't write the question of parametric.
Sir, I think you didn't given only one question, I think so.
Yeah, sir. At the last you have given.
Yes, sir, that is one equation in the locus.
In between, I did not give one parametric equation. We discussed a lot of parametric equations yesterday. No.
Yes, sir, but you
Yeah, sir,
didn't
but
give.
you just solved. You didn't give any homework. You had
Yes,
given the last equation.
Okay. Then
only one.
I'll give that to you homework today. No problem. So we'll go with the problems today.
Sir?
So the first problem that we'll be solving, please take the question. The base of a triangle. The base of a triangle lies along. The base of a triangle lies along x is equal to a. The base of a triangle is
Sir, your voice is not clear.
base. The base of a triangle is along x is equal to a, means is lying along, is resting upon x equal to a. So the length of this base, the length of the base is equal to a units. The length of the base is equal to a units. And the area of triangle, the area of triangle is equal to a square. And we have to find the locus of the other vertex. Now what they're telling is, let us take some x, this one. So x is equal to a is a vertical line parallel to x-axis. So this is my x-axis, this is my y-axis, and x is equal to a. Let us say this is the equation, this is a line of equation x is equal to a. And the base of my triangle is lying on this axis. The base of my triangle is lying on this axis. That means, let us say the base of my triangle is somewhere like this. So my base of triangle A B is lying on this side. This x is equal to a line, and the length of this is equal to e. Here the length is a. That find the locus of this other vertex. This vertex is locus we have to find.
Sir, I didn't understand.
The question that is the base of the triangle. There is one triangle. The base of the triangle is resting upon the equation x is equal to e. X is equal to a is a equation of a line parallel to y-axis. So there is a line parallel to y-axis. Equation is equal to x is equal to line is parallel to one opposite direction. Line is resting upon the equation. So line is
Sir, your voice isn't clear, sir.
Your voice is not clear.
Yes,
Chandrika ma'am?
one
Ma'am,
second. Yeah, Vignesh.
ma'am, sir is not there.
Yes, Vignesh, one second. I think sir has a bad weather. Uh, just a second. Just a second, students, please wait. Yes, students, sir has a bad weather. He cannot join now. I would request Arun sir to continue. Just a second, sir has joined.
Hello? Is
Yes,
it
sir.
audible now?
Yes, sir, you're audible, sir. You're audible, sir.
Okay, ma'am.
Yes.
So, A and B should be here. And
Sir,
one thing that
can't
they're
see your
telling is
screen.
that
Sir, we can't see, sir.
hello.
Yeah, sir.
Yes, sir.
Please wait for a few minutes, students. Sorry for the technical issue from sir end. Please wait for a few minutes.
Just a minute. Is the screen visible now?
No, sir.
No, sir.
Distance?
No.
Screen is not visible.
No, sir.
Now what about now?
No, sir, it is not visible.
White screen is not visible?
No, sir.
Just a minute.
Okay.
Distance, is it visible now?
No, sir.
White screen is not visible.
No, sir, it is not visible.
The mobile screen is visible.
No, sir.
Yes, students. sir is facing some technical issue due to a bad weather. So I would like to invite Arun sir to continue the session. Please bring your physics books.
All right, ma'am. Thank you, ma'am.
Yes, sir. Thank you, sir.
Good evening, sir.
Yeah, good evening, Divya.
Good evening, sir.
Hi, good evening, Atri.
Good evening, sir.
Yeah, good evening. Who is it? The end?
Ashrita, sir.
Oh, hi, Ashita. Good evening.
Good evening, sir.
Hi, Omkar. Good evening. Just a second. Just give me a minute. Let's start. Okay. Oh, it's in the spotlight. Fine. Great. All right. So we'll do one thing. We'll because only MPC students are here. One AX graph, which we have visualized in the morning, we'll completely solve it in detail. All right. Because we have only MPC students, we can go to any level. All right. Okay. In the morning, I would have to restrict myself to keeping Neet students in mind as well. But right now, we have got only MPC students. We can go to any level. All right, agreed? Ready for that?
Yes, sir.
Yes, sir.
All right, all
Yes.
right. Okay. Now look at this. I'll begin from beginning. Please follow carefully. Even if you have got any kind of doubt, please ask.
Sure, sir.
I've got AX graph like this. So let the equation be A is equal to minus X. That's it. All right. That means this angle is 45 and
Yes,
this
sir.
angle is 135. All right.
Yes, sir.
A is equal to minus X. Slope is 1 minus 1. So this angle would be 135 and this angle would be 45. But now I told you there are two AX graphs which are very important. One is this one, the other is positive slope and negative slope. There is hell lot of things to talk about these two graphs, but we'll eventually talk. All right, once we grow intellectually, just a second, students. Once we grow intellectually, we'll be in a position to discuss more and more. All right, once we enter into kinematics in 2 dimension, then we'll enter into mechanics. Sorry, Newton's laws, friction, work energy. We'll come back to this graph again and again. But right now we are doing it from kinematics perspective. Only what is happening to the motion without discussing the cause of motion. All right. Now let us say this origin. What is the acceleration at origin, students?
0, sir.
0, sir.
Zero, right? All right. Now, if I leave a particle here, so if I leave a particle at origin, what will happen to the particle? If I release a particle at origin, what will happen to the particle?
Does not change.
It will be changed.
It remains
More.
there forever,
Yes, sir.
right? It doesn't change, right? That's right. Absolutely right. Medha, you are able to follow? Sri Medha,
Yeah, sir.
you're able to follow?
Yes, sir.
All right. Please interrupt if at all you are not able to follow. Please let me know. All right.
Okay, sir.
Okay. Now, let us say I leave a particle at this point with minus x naught. What would happen?
Retard. It will
Towards
be
which direction? Towards which direction will the particle go? Towards right or towards left?
left.
Left, sir.
Left, sir.
No, look at the acceleration. Acceleration will decide. So is the acceleration positive or negative?
Negative, sir.
Acceleration చూడండి. At this point, acceleration is positive కదా. So
Yes,
at
sir.
minus x naught. A is equal to minus x naught చేస్తే a is equal to x naught వస్తుంది. Positive
Yes.
ఉంది.
Yes, sir.
Right?
Towards right, sir.
Towards right, exactly. So it'll start accelerating towards right. కొంచెం ముంగట వస్తుంది, velocity gain అవుతుంది, speed gain అవుతుంది, but acceleration is still towards right. Acceleration is reduced, but still towards right. అయితే
Yes.
ఇంకా speed pickup అవుతుంది. So acceleration is further reduced, but it is still towards right. అయితే ఇంకా accelerate అవుతుంది, speed gain అవుతుంది. Now at origin, let's say it gains a speed of v naught. For instance, at origin, its speed is v naught. Now, what happens because of this v naught? There is no acceleration at origin. Will the particle move ahead?
Where, sir?
Yes.
Yes,
The
sir.
particle will move ahead because it has got velocity. Velocity
sir.
will decide whether the particle is going to move or not when not at rest. I mean, velocity is something which will tell you particle is moving. And the particle is moving because it has got some velocity.
It's moved, sir.
Acceleration will decide only when the particle is at rest. Particle rest lo unnappudu, then acceleration will decide whether the particle will move or not. But when the particle is moving, it has got some velocity. So particle is evident it's moving. If it has got some velocity, it is very evident that this particle is moving in certain direction. All right. Now, because of which it will overshoot. It will cross this point. At this point, what happens? Acceleration is positive or negative?
Positive.
Negative.
Negative, sir.
Negative, right?
Negative, sir.
So velocity is positive, acceleration is negative. What will happen to the speed? Increase or decrease?
Decrease, sir.
Jesus.
Decreases. That's right.
Decreases, sir.
Be confident. Be confident. You're all thinking well. Be confident. All right. So it decreases. It goes to right, decreases, further decreases. It will stop symmetrically at a point plus x naught.
Yes,
Minus
sir.
x naught దగ్గర వదిలేస్తే plus x naught దగ్గర symmetrically stop అవుతుంది. That is the physical analysis says. Graphical analysis also says the same thing in the X graph. Now, let us write the equations for this one. Okay, what would happen if I project a particle towards left with some velocity? అప్పుడు ఏమవుతుంది?
Retard అవుతుంది, sir.
Yes, sir.
Right, retard అవుతుంది. It will go towards left, stop, and then come back.
It is opposite to acceleration.
Yeah, so let's say it stops at somewhere at x naught prime. Till where will the particle go on right?
X naught prime plus x.
Not prime.
Plus x naught prime. You're right.
Not prime to plus
Minus
x.
x naught prime దగ్గర వదిలేస్తే plus x naught prime దగ్గర వెళ్తుంది. So if I project a particle at x naught towards left, it will come, stop at minus x naught prime. From here it will start again like as it start from x naught. మళ్ళీ rest లో వచ్చేస్తుంది. Rest ఉంది, velocity లేదు, but there is acceleration because of which the particle starts moving in the direction of acceleration. So it will start moving towards right. It will go origin దగ్గర వెళ్ళి maximum speed acquire అయ్యి మళ్ళీ x naught prime దగ్గర వెళ్ళి ఆగిపోతుంది. మళ్ళీ వెనక్కి వస్తుంది. మళ్ళీ so it goes on forever. So this is an oscillation. All right.
Yes, sir.
Okay, now let us
Sir?
write the equations for this one. Yes,
ఇక్కడ
Yes, Vignesh.
x naught prime ఎంత వస్తుంది, మైనస్ x naught prime.
minus x naught prime ఏమైందంటే x naught దగ్గర నేను పార్టికల్ ని
No, sir.
towards left.
సార్ నా కాన్సెప్ట్ అర్థమైంది, కానీ ఒకవేళ వాల్యూస్ ఉంటే -5 వెళ్తే అక్కడ సైడ్ ఐ మీన్ ఎక్స్ యాక్సిస్ వెళ్ళక 5 దగ్గర ఆగిపోతుందా?
ఇది 2 నుంచి నేను వెనక వదిలేస్తే 5 ఉంది అనుకోండి, ఇది -5 దగ్గర ఆగింది, ఇది వెళ్ళి +5 దగ్గర ఆగిపోతుంది.
ఓకే సార్.
ఆల్రైట్.
ఓకే సార్.
Okay, now let us see the equations. I've got a is equal to minus x. So I can write v dv dx is equal to minus x. So v dv minus x dx. Now I integrate this. I integrate from where to where? Initial position of the particle is minus x naught.
X naught.
V
What
naught.
is the velocity? What is the velocity at this point? See, always whenever you substitute the limits, you do it this way. Corresponding limit substitute చేయండి. ముందు minus x naught ఉన్నప్పుడు velocity ఏముంది?
x naught.
V naught. sir. V naught.
V naught.
No, x naught. X naught అంటే particle రిలీజ్ చేశారు.
Zeros.
0. When the particle is at certain point x, what is the velocity? Some v.
E naught.
So I get the equation now. అదే నాకు డైరెక్ట్ I want velocity at origin కావాలనుకోండి, what do? I'll substitute this as 0 and I get velocity as v naught. If I solve this, I'll get velocity v naught at origin. ఓకే, డైరెక్ట్ ఆరిజిన్ దగ్గర వెలాసిటీ అడిగితే నేను ఇలా చేస్తున్నాను. ఆర్ డైరెక్ట్ వన్ పర్టికులర్ పాయింట్ దగ్గర అడిగితే లెట్స్ సే -x0 to x0 అడిగాను అనుకో, నాకు x0 వరకు వెలాసిటీ కావాలి. సో ఐల్ రైట్ 0 to v0 -x0 to x0. I'll get velocity at x0. All right, but if I want the function, then this will also be a variable. From -x0 to x, 0 to v. x0 నుంచి x వరకు వెళ్తే or some x వరకు వెళ్ళింది అనుకోండి, -x0 to x is velocity is from 0 to v. All right, now let us further solve it. Integral x dx ఏంటి చెప్పాను నేను. I'll give you the formula list. All right, give me a day's time. v square by 2 under limit 0 to v,
Yes,
which
sir.
is equal to
Yes, sir.
equal to
X square by 2.
X
square by 2.
x square by 2. Excellent. Under
Min-
limits -x0 to x.
Minus x0 to x.
Excellent. Now let us substitute the limits, upper limit and then lower limit. Upper limit 2 cancel అయిపోతుంది కదా. సో అప్పర్
Yes,
లిమిట్
sir.
సబ్స్టిట్యూట్ చేస్తే v స్క్వేర్ వస్తుంది. -0 స్క్వేర్ is equal to, ఇది -x కదా, I forgot there is a -x here. ఇది -x. All right, so -x square by 2 వస్తుంది.
Yes, sir.
So I'll substitute upper limit first. -x square minus of -x0 whole square. Is it clear?
Yes, sir.
Yes, sir.
Now look at this. This is anyway 0. This is gone. So I'll write this as v square is equal to -x square minus of minus x0 square.
Minus x0 square. Minus x square plus x0.
No, sir. -x square minus x0 square.
X0 square minus x square. V square.
x0 square minus x square వస్తుందా?
Yes, sir.
No, sir.
Okay,
Plus
we'll do one
వస్తుంది.
thing. We'll do one thing. We'll remove this minus here. We'll remove this minus here and invert the limits here. This becomes x. This becomes x0. Now I'll substitute the limits. So x0 square minus x square. Yes, you're right. Yeah, be careful with my math. Okay, when I do, be careful. Okay, keep cross checking. Sometimes I commit mistakes. Plus minus no mistakes చేస్తాను. All right. Thank you.
ఫస్ట్ కూడా మీరు
ఇక్కడ ఏం
కరెక్టే
చేశాను?
సార్.
కరెక్టే కదా?
ఫస్ట్ కూడా కరెక్టే.
Okay,
Yes,
okay,
sir.
fine.
Change చేశారు sir అంతే.
Okay, just minus తీసి ఫ్లిప్ చేస్తే కొంచెం ఈజీ అనిపించింది నాకు అంతే.
ఓకే.
Okay, ఇది ఇన్వర్ట్ ఎలా చేశాను తెలిసింది కదా. Whenever I remove a sign, negative sign, I can invert the limits. Right? So ఇన్వర్ట్ చేస్తే నాకు ఇది వచ్చింది. So v square is equal to, sorry, v square minus x square ఇటు తెచ్చుకుంటే v square plus x square is equal to
X0 square.
Now this is a conic section. All right. Tomorrow I'll show you some conic sections, but right now, no, tomorrow is a doubt session. All right. Okay. And one more thing. Tomorrow, it's a holiday, no?
Yes, sir.
Yeah.
No,
Okay.
No, sir.
Holiday.
No, sir.
No holiday.
Half
Alright,
day,
so the
sir.
half day. Okay.
Yes, sir.
Okay.
No
Okay.
holiday.
So can we plan? Can we plan a class in the afternoon?
యా
No,
సార్ వి కెన్
Yes,
ప్లాన్.
sir.
Yes, sir.
Someone said no.
Yes, sir.
Yes, sir.
Plan చేయొచ్చు కదా
Yes, sir.
class?
యా.
No. No, sir.
Why?
No,
Has college.
this sir.
భావన ఉందా? ఈవినింగ్ వరకు ఉందా మీకు?
Yes, sir.
Okay.
Full
కొత్త
day.
స్టూడెంట్స్ కి all the new students?
వి హావ్
Half day, sir.
12:40 సార్.
All the new students. Yeah, please
Yeah.
raise your
12:40,
hand who are okay for the afternoon class. Please raise your hand. Or just tell me your names. Okay, Srimeda, Divya, Vignesh, others, just a second. Okay, Shravani. Okay, so for Prema and Ashrita, it's not okay. Rizwan is not okay. Bhavna is not okay. But Bhavna is an old student. I'm talking about the new students. Okay, Prerna is okay. Shiva, Bhaskar. Pavan, it's not okay. So new students के अंदर की okay लेदा. Okay. Okay, so let us. Okay, we will discuss with madam also. ఒకసారి చంద్రిక madam to discuss చేసి we'll plan class in the afternoon.
Okay,
All
sir.
right. All right, because we can do some backlog sessions, or we can go for even better problems, deeper problems.
Okay,
Alright.
sir.
Okay,
Huh.
sir.
Okay, now look at this. What kind of equation is this? It's the equation of a circle. X square plus y square is equal to r square. Coefficient of x is 1, coefficient of y is 1, and I've got a r square, radius square. So it's a circle, perfect circle. What is the center of the circle?
Yes, sir.
Origin. Center of the circle is origin. In this case, it's origin. Right? If you have 2gx plus 2fy, then the center is shifted. G is equal to 0, f is equal to 0. So center is origin. Okay, now let us plot this one. I'll just write this equation separately. So vx square, if I say this is x and this is v, this radius is x naught. All right. Let's say radius is 4, r is 2, so this will be 2. Another radius is 5, 3, 4, 5. This is how I'll get velocity versus x graphs. Now, look at this. There is one more point here, that I've got one more point in the center, which is part of the graph. So I'm getting family of circles. My radius varying from 0 to infinity. I'm getting family of circles. Circles ఉన్నాయి కదా, అన్నిటికీ ఒక ఈక్వేషన్, కామన్ ఈక్వేషన్ వచ్చింది కదా నాకు. V square plus x square is equal to x naught square ani. Whenever you plot such functions, such curves, what you get is a family. It's called a family. Technically, it's called family. Alright, in conic sections in mathematics, it's called family of curves. These are family of concentric circles with radius varying from 0 to infinity and with centered at origin. Alright, now let us see. Let us interpret. Now, as we have interpreted this graph, correlated this graph with a physical scenario, here also we'll do the same thing. We'll see at certain point, now velocity ఎలా ఉంది, particle ఎలా వెళ్తుంది, right వెళ్తుందా, left వెళ్తుందా, alright, both sides వెళ్తుందా, అది impossible. Alright, so let's talk about physical scenario corresponding to this graph. Alright, now you understood the graph. Now graph ఎలా ఉంటుంది, you'll have concentric circles. నేను x naught దగ్గర వదిలేస్తే ఇక్కడ నుంచి వస్తుంది, 2x naught దగ్గర వదిలేస్తే ఇక్కడ నుంచి వస్తుంది, 3x naught దగ్గర వదిలేస్తే ఇక్కడ నుంచి వస్తుంది, x naught by 2 దగ్గర నుంచి అయితే ఈ కర్వ్ వస్తుంది. సో ఐ గాట్ ఫ్యామిలీ ఆఫ్ కర్వ్స్. నేను ఎక్కడ వదిలేస్తే దాన్ని బట్టి ఆ సర్కిల్ వస్తుంది. ఆల్రైట్, ఇస్ ఇట్ క్లియర్?
So can you
Yes,
repeat?
sir. Sir,
Okay.
can you write big size?
Yeah. What is to be written big here? These coordinates.
Yes, sir.
Not the alphabets.
Alright. This also. V square plus x square, x naught square. That's okay?
Yes, sir.
That is visible now? Sorry, I have a bad habit. I'll slowly eventually change. Alright, కొంచెం చిన్న రాస్తాను, మళ్ళీ పెద్ద గుర్తు వస్తుంది, మళ్ళీ పెద్ద రాస్తాను. Alright, sorry for that. Okay, and thank you for reminding. Alright, now at certain position x naught, let's say one circle will appear on the Vx graph, but Vx graph is a family of curves. Vx graph is a family of curves. Ante for one particular x naught, I'll get one particular curve. another particular x, 2x naught, 3x naught, or x naught prime, 2x naught prime, x is equal to 3, 2.2, 2.3, ax value unna kuda I'll have one particular circle for that on the Vx graph. When you have family of curves like this is called a portrait. Why is it called a portrait is, let us say I have one of you, let's say Vignesh. All right, I've got sketch of Vignesh. Okay, sketch undi Vignesh di, photograph ledu, sketch undi. A sketch చూసి నేను చెప్పొచ్చు కదా Vignesh, okay, Vignesh looks like this, he wears specs, all right, he has got this kind of hairstyle, okay, he looks like this. I can look at this sketch and recognize Vignesh. If I have a sketch of Vignesh, I can recognize Vignesh looking at the sketch. So that means this is called a portrait of Vignesh, right? This Vignesh portrait, looking at which I can recognize Vignesh. So looking at this graph, I can recognize the whole phenomena, whole motion. That is why this is called a portrait. అంటే ఇది చూస్తే నాకు ఫినామినాది మొత్తం పిక్చర్ వచ్చేస్తుంది. పార్టికల్ ఎలా మూవ్ అవుతుంది, ఎప్పుడు ఎలా మూవ్ అవుతుంది, ఎక్కడ పార్టికల్ ఈ ఇన్స్టెంట్ లో ఎక్కడ ఉంది, దాని తర్వాత ఎక్కడ వెళ్తుంది, ఎక్కడి వరకు వెళ్తుంది, ఓకే, అది మొత్తం సినారియోది పిక్చర్ ఇది చూస్తే వచ్చేస్తుంది. So this is called technically called portrait. All right, there is one more term here that's not required, but that's technically called portrait. It's called face portrait, but right now in the footnote you write down face portrait. Footnote lo face portrait and rayandi. We'll come back to this point again in Newton's laws. Okay, now this is called a portrait. So now what I mean to say portrait, ante meeku edaina Vx graph iste, you should be able to talk about the whole of the motion. All right, let's say you are new to some phenomena, either motion icharu, then you should ask for a Vx graph. Now Vx graph iyandi, I'll understand the motion, because Vx graph is a portrait of the motion. Vx graph lo you'll have a lot of information hidden in the Vx graph about the motion. Particle ekkadi nunchi start avutundi, ekkadi varaku veltundi, enta speed gain avutundi, overshoot avutundi, ekkada overshoot ayyundi, ekkada turn avutundi, anni మనం తెలుసుకోవచ్చు particle ది from Vx graph. So Vx graph for A is equal to -x is simple, family of circles. But Vx graph for y is equal to A is equal to x. The other graph, morning draw chesanu, hyperbola వచ్చింది. That is critical. All right, that's very confusing. That's very difficult also. And that's very important also. See, advanced అలాంటి ఎగ్జామ్స్ కి డిఫికల్టీ ఇంపార్టెంట్ ఉంటుంది. డిఫికల్ట్ ఇన్ సెన్స్ విచ్ ఇస్ మోర్ క్రిటికల్ ఇన్ థింకింగ్ ఇస్ వెరీ ఇంపార్టెంట్ ఫర్ అడ్వాన్స్డ్. ఎందుకంటే అడ్వాన్స్ లో దే విల్ చెక్ యువర్ థింకింగ్ ప్యాటర్న్, ఎంత క్రిటికల్ క్వశ్చన్ అటాక్ చేస్తున్నారని చూస్తారు. So more the critical the question is, more the critical the thought process is, that's more important for the advanced exam. All right, now so for A is equal to -x, my face portrait is like this: concentric circles, family of concentric circles centered at origin. For A is equal to x plus x, my family is rectangular hyperbole. Okay, rectangular hyperbole for A is equal to x. You can write down, note down. Rectangular hyperbole. For what? For A is equal to x. All right, that we will talk about it later. But we did the discussion, visualization చేసాము మార్నింగ్. A is equal to x today morning చేసాం కదా. ఇక్కడ నుంచి పార్టికల్ వదిలేస్తే ఇన్ఫినిటీకి వెళ్ళిపోతుంది, ఇక్కడ నుంచి వదిలేస్తే ఇన్ఫినిటీకి వెళ్ళిపోతుంది, ఇక్కడ నుంచి ప్రొజెక్ట్ చేస్తే 0 వరకు వస్తుంది, 0 క్రాస్ చేస్తే వెళ్ళిపోతుంది. ఇవన్నీ చూసాం కదా. గుర్తుంది కదా అందరికి?
Yes, sir.
So now let us look at this face portrait. ఈ face portrait చూద్దాం ఇప్పుడు. Now I'll erase family తీసేసి I'll just pick one particular curve for one particular x naught. సరేనా? So I'll remove all these. There is lot to speak on this in mechanics. ఇంకా ఒక ప్రీవియస్ అడ్వాన్స్ ప్రాబ్లం కూడా వచ్చింది, చేపిస్తాను. అండ్ ఇన్ దట్ కేస్ హి హస్ డిఫైన్ వాట్ ఇస్ పోర్ట్రేట్. పారాగ్రాఫ్ క్వశ్చన్ వచ్చింది, పారాగ్రాఫ్ లో పోర్ట్రేట్ ఏంటని ఎక్స్ప్లెయిన్ చేశారు. అప్పటి వరకు పోర్ట్రేట్ సిలబస్ లో లేదు, బట్ పోర్ట్రేట్ ఎక్స్ప్లెయిన్ చేసి దాని మీద క్వశ్చన్ అడిగారు. ఆల్రైట్, సో థింగ్స్ కెన్ బి లైక్ దిస్ ఇన్ అడ్వాన్స్ ఎగ్జామ్. you can have something new idea over there. Our new idea కూడా apply చేయగలగాలి. So I'm telling you this new idea pre-hand. So you are discussing portrait pre-hand. Portrait ఇప్పుడు సిలబస్ లో అప్పుడు లేకుండే పోర్ట్రేట్ వర్డే లేకుండే ఎప్పుడు ఎవరు చెప్పలేదు పోర్ట్రేట్. బట్ వన్స్ దట్ హాస్ అపియర్డ్ ఇన్ ఎగ్జామ్, బట్ ఐ యూస్ టు డిస్కస్ పోర్ట్రేట్ బిఫోర్ ఆల్సో. ఆ ఎగ్జామ్ వచ్చిన ముందు కూడా పోర్ట్రేట్ నేను డిస్కస్ చేశాను. ఆల్రైట్, సో ఫార్చునేట్లీ ద స్టూడెంట్స్ హూ ఆర్ మై స్టూడెంట్స్ కుడ్ ఆన్సర్ దట్ క్వశ్చన్ వెరీ ఈజీలీ. So sometimes that happens, what you discuss sometimes can appear in the question. Okay, now look at the students at certain point x naught. All right, I have taken x naught square, ఈ సర్కిల్ తీసుకున్నాను. సో రేడియస్ ఇస్ x naught, this will be minus x naught. ఈ వాల్యూ ఎంత ఉంటుంది? ఈ ఇంటర్సెప్ట్ ఎంత ఉంటుంది? I substitute x is equal to 0. If I substitute x is equal to 0, I'll get v is equal to plus or minus x naught. Plus or minus x naught. Radius x naught కదా?
Yes, sir.
So x naught is equal to 5
Yes, sir.
తీసుకున్నాము. Because sometimes numbers are more convenient. For you, it could be convenient. But for me, symbols are more convenient. So numbers convenient అనుకుంటే x is equal to 5 తీసుకుందాం. So at x is equal to 5 meters, this is v origin వచ్చినప్పుడు v is equal to 5 meters per second. Alright, units are different. Length same ఉంది, but units are different. ఇక్కడ 5 meters ఉంది, this is 5 meters per second ఉంది. Alright, vertical axis meters per second, horizontal axis meters. Now look at this, students. If I have a particle here, what's the velocity of the particle at that point is the question. ఎలా కనుక్కుంటాను? I'll draw a vertical line. So there are two intersections now. ఇక్కడ ఒక intersection, ఇక్కడ ఒక intersection. So two velocities వచ్చాయి, positive and negative. So can the particle have two velocities at the same instant? Impossible కదా. Particle cannot go in two directions at the same time. Positive velocity ఇంకా negative velocity, it cannot have at the same time. Positive and negative, it cannot have at the same time. That's impossible. That doesn't make sense at all. The particle cannot have velocity in this direction and also in this direction at the same time. Either it will go in this direction or it will go in this direction, one particular direction. It can have component in other directions. Velocity component ఉండొచ్చు, but absolute velocity, net velocity ఒక direction లోనే ఉంటుంది. Agreed? You will not have velocity in two directions at the same time.
Yes, sir.
So what does it mean? Then how do we resolve this conflict? Now two velocities వచ్చాయి కదా, at a point x, two velocities వచ్చాయి. What does it mean is, at one particular time, the particle is going towards right. At other particular time, after some time, it is coming towards left. So it is going towards right, it's coming towards left. So this particle is crossing this point two times. Once going towards right, once going towards left. All right. Now, as the particle reaches this point, here also it will have two velocities, one going towards right, one going towards left. చిన్నగా ఉంటుంది, but vector will be smaller because it is coming closer to the x-axis. My velocity is decreasing. As I reach x naught, what is the velocity at x naught? My curve is intersecting x-axis.
Sir.
What is the velocity at x naught?
0, sir.
Right, 0.
0.
This is the origin. So velocity is 0. So particle stops over there. But because it has an acceleration, it will come back. కానీ నాకు యాక్సలరేషన్ టైం గ్రాఫ్ ఇవ్వలేదు, యాక్సలరేషన్ ఎక్స్ గ్రాఫ్ ఇవ్వలేదు. ఇది ఇచ్చాము, ఇక్కడ నుంచి పోర్ట్రేట్, ఇది పోర్ట్రేట్ అనుకొని మొత్తం పార్టికల్ ఎలా మూవ్ అవుతుంది చెప్పగలవాలి. ఆల్రైట్, వీ డోంట్ హ్యావ్ ఏఎక్స్ గ్రాఫ్ నౌ. ఏఎక్స్ గ్రాఫ్ మనం ఆలోచించాము, దట్స్ ఓవర్. ఏఎక్స్ గ్రాఫ్ నుంచి కూడా తెచ్చుకోగలుగుతాము, బట్ విఎక్స్ గ్రాఫ్ ఇస్ ఎ పోర్ట్రేట్. ఐ టోల్డ్ యూ, పోర్ట్రేట్ అంటే ఫర్ ఎనీ కైండ్ ఆఫ్ ఎక్స్ నాట్, ఫర్ ఎనీ కైండ్ ఆఫ్ ఇనిషియల్ కండిషన్, ఫర్ ఎనీ కైండ్ ఆఫ్ ఇనిషియల్ వెలాసిటీ, ఫర్ ఎనీ కైండ్ ఆఫ్ ఇనిషియల్ ఎనర్జీ. ఎనర్జీ గురించి కూడా మాట్లాడాలి. వెన్ యూ కమ్ టు ఎనర్జీ, సేమ్ పోర్ట్రేట్ విల్ టాక్ అబౌట్ దిస్. దట్స్ ఐ హావ్ టు రైట్ ఫుట్ నోట్ లో ఫేస్ పోర్ట్రేట్ అని రాయమన్నాను. సో దట్ వెన్ వి కమ్ టు ఎనర్జీ చాప్టర్, వి విల్ టాక్ అబౌట్ ద సేమ్ ఫేస్ పోర్ట్రేట్ ఇన్ టర్మ్స్ ఆఫ్ ఎనర్జీ. ఆల్రైట్, ఓకే. నౌ ద పార్టికల్ is going to come towards left. ఎలా చెప్పగలుగుతాను? Because my velocity is going to be negative at this point. Every face portrait has got something called flow. Students, say something. Am I able to hear you? Say something.
Yes, sir.
Okay. Able to
Yes,
hear you.
sir.
Dinesh, I'm able to hear others. So check the problem at your end. All right, let's come back to this one. Let's not get deviated. So when the velocity is positive, my particle is going towards right. So on a graph, ela chupistanante with the arrow I'll show like this. Particle ikkada unnappudu arrow will be like this. So arrow is like this. Arrow is like this. So phase portrait is complete. I told you in basic maths class. Sorry, kinematic class lo cheppanu. Graphs class lo VX graphic analysis చేసినప్పుడు చెప్పాను. That VX graph is complete only with an arrow. Arrow వేస్తే then VX graph is complete. But arrow will tell me how the particle is moving. ఇక్కడ నాకు particle కావాలనుకోండి at this point x and the velocity is positive. That means the particle is going towards right. So and over here particle is going towards right, and when the particle is velocity is this one negative, particle is going towards left. So particle is oscillating between these two. See, my VX graph is bounded. It's within the region. ikkade undi. So particle is going to oscillate. All right. If the VX graph is not bounded, it will go away from origin. It will go away from origin, as in the case of AX to X graph. E graph కోసం ఎలా వచ్చింది మనకి analysis? Particle is going away from origin to infinity, or it's going from origin to infinity, negative infinity or positive infinity. That time my graph will be unbounded. That's why you'll have rectangular hyperbola. Hyperbola is an unbounded graph. Right? Unbounded graph. Unbounded ante it is not confined to the region, but circle is confined to a region. Bounded graph ante bounded curve ante it's confined to a region. That's called bounded curve. All right. In loose terms. Okay.
Sir, I'm audible now.
Yeah, you're audible now. Yes,
Yeah,
Vignesh.
okay.
Okay. Now look at the students. ఇంతకు ముందు ఏం అనుకున్నాం మనం నాకు ఏమొచ్చింది VX square is plus X square is equal to 5 square. That's my equation of the circle. So one circle out of the whole portrait is this one. Now, if I leave the particle at 5 by 2 or minus 5 by 2, all right. So with what velocity should I leave the particle at minus 5 by 2 such that it should reach 5? Or how will I find velocity at minus 5 by 2? Minus 5 by 2 దగ్గర velocity ఎలా కనుక్కుంటాను? I'll draw a vertical line. This is my velocity or this is my velocity. If the particle is going towards right, positive velocity. If the particle is going towards left, negative velocity. I'll substitute minus 5 by 2 over there. I'll get velocities. All right. Students, able to follow?
Yes, sir.
Yes.
Okay. Now this radius x0 square, x0 is radius. X0 square also has got a physical significance. All right. This x-axis, y-axis, and x0 square also has a physical significance. I'll show you what the physical significance is now. Oh, can I erase this? Yes. What you do is you try to get the equation of phase portrait for A is equal to X. All right. Surely I had VdV is equal to VdV by dx is equal to A. Right. So dx is equal to VdV is equal to A dx. I integrate this from x0 to x0 v0 to x0 to v. Let's say at x0 I have a velocity v0, more general case. At x velocity is v. Now a తెలియదు, a function తెలియదు. ఇక్కడ a function a is equal to x minus x ఉంది. But general a ఉంటే it could be minus x or plus x or anything. ఇది ఈక్వేషన్ ఉంటుంది. velocity acceleration velocity position equation ఇది ఉంటుంది. Now what do I get? V square minus v0 square by 2 is equal to integral x0 to x a0 dx. So 2 ఇక్కడ నేను 2 ఇక్కడ పెడతాను. Now what I do, I multiply with m on both the sides. Right? I multiply with m on.
Again. So can
Sorry?
you repeat?
Can you repeat the explanation once again, sir?
Yeah, sure. See. Okay, I'll do one thing. I'll erase this for a minute. Okay, I've got AX curve. This we have done in graphical analysis, but most of you have missed the class and you don't have access to record it now. So we'll do everything again. Don't worry about it. See, we'll go slow, we'll go strong so that we don't be wrong. మెల్లగా వెళ్దాము, but let's go steadily. Let's go slowly and steadily. Initially, then we'll pick up the pace. All right. Now, what I do, integral x dx now, integral v dv. What is integral v dv? V square by 2. V square by 2 under limits v naught to v is equal to integral. Now, a function telidu. That's why I'll leave it as integral only. Now, I substitute the upper limit, lower limit. V square by 2 minus v naught square by 2 is equal to integral a dx x naught to x. Now what I do, I multiply with m on both the sides. Mass of the particle. From your school knowledge, you might have at least heard about it, that kinetic energy is half mv square.
Yes,
Yes.
sir.
Yeah. Now look at this. What is this integral a dx x naught to x? It is nothing but area under the x naught ax graph. Right? It's nothing but area under the ax graph.
Yes, sir.
Any definite integral is nothing but area under the ax graph. The ones who were there previously, but new students may not understand this. Any definite integral is nothing but area under the ax graph, or any area under fx graph. Okay, graph on the fx graph on the ila undi. I want area between x1 to x2. My definite integral will give me x1 to x2. F of x dx is my area under the graph. If this is f of x, so area under the graph is given by integral f of x dx from x1 to x2. So under limits x1 to x2, from between the lines x1 to x2 and area under the fx graph is given by this definite integral. So what is the definite integral here? A dx, integral a dx. So what is a? A is varying like this. A's graph is like this. So integral x0 to x in a dx would be area between x0 and x, two vertical lines, under ax graph. Under ax graph. So this area is given by this one.
Yes, sir.
All right. So this area is negative kada. Zero x-axis is negative kada.
Yes, sir.
Yes,
Keep
sir.
that in mind. Now, what is left hand side? Final kinetic energy, initial kinetic energy. Final kinetic energy minus initial kinetic energy, which is delta Ke. So delta Ke is nothing but area under the ax graph. Always remember. Area under the ax graph is nothing but delta Ke. Delta Ke and change in kinetic energy. Under final kinetic energy minus initial kinetic energy is area under the graph. So I can give you ax graph and ask you what is the kinetic energy at certain point. Origin దగ్గర kinetic energy ఇచ్చేస్తాను, or at a point kinetic energy ఇస్తాను, initial kinetic energy ఇస్తాను. I'll ask you final kinetic energy and I'll give you ax graph without giving any function. Just graph ఇస్తాను. Function అక్కడి నుంచి just triangle trapezium తెచ్చుకొని I'll just substitute the area. I'll get the area. Delta K is equal to area. Final is equal to final minus initial is equal to area. Final is equal to initial plus area. Right?
Sir, emit పోతుంది sir. Mass.
Mass ఇస్తారు. Mass will be given to you.
Oh.
ఓకే 2 kg 3 kg 5 kg 2 kg తీసుకున్నాను. ఇక్కడ నేను 2 kg తీసుకున్నాను, అందుకే 2 క్యాన్సిల్ అయిపోయినాయి అన్ని. రైట్.
Yes, sir.
ఓకే. అండ్ దెన్ నౌ లుక్ ఎట్ ది స్టూడెంట్స్. ఇప్పుడు ఏఎక్స్ గ్రాఫ్ నుంచి ఏం చెప్పొచ్చు నేను? డెల్టా కే ఈజ్ కూడా ఏరియా గ్రాఫ్ ఇస్ నెగటివ్ వస్తుంది నాకు. రైట్. దట్ మీన్స్ మై ఫైనల్ కైనెటిక్ ఎనర్జీ is lesser than initial kinetic energy, and that is what is happening in the motion also. No, ఇక్కడ ఏదో వెలాసిటీ ఉంటే రిటార్డ్ అవుతుంది పార్టికల్. ఇక్కడ ఏదైనా వెలాసిటీ ఉంది అనుకోండి, x0 దగ్గర v0 ఉంది, సో పార్టికల్ is being retarded till x. By the time it reaches x, its speed is decreasing.
Yes, sir.
That means its kinetic energy is decreasing, and that is what the equation also says the same thing, right? Delta k is area under the graph, which is negative. So delta k is negative ante final is less than initial. So half of v0 square initial velocity unte, initial kinetic energy unte, final kinetic energy is less than this one. That means particle has retarded.
Yes, sir.
So area under the ax graph is very important curve, which gives me change in kinetic energy into mass, of course. Mass into area under the ax graph, mass into this one. If mass is not there, then that doesn't have any physical significance. area into mass will give me change in kinetic energy. Mass ఇవ్వలేదంటే it doesn't have physical significance. Mass ఇస్తేనే mass into area is change in kinetic energy. All right. So students, one simple this thing. Tomorrow we'll try to meet in the afternoon. Let's plan for the class. But before that, all you have to do is just do one thing. Very simple thing. I've got v dv dx is equal to ఇప్పుడు ఏ గ్రాఫ్ ఇలా తీసుకుందాం, అన్బౌండెడ్ మోషన్. ఇలా ఉంటే బౌండెడ్ మోషన్ ఉండే, ఇప్పుడు అన్బౌండెడ్ మోషన్ కోసం తీసుకుందాము. సో ఎక్స్ తీసుకుందాము, ఎక్స్ ఫంక్షన్ తీసుకుందాము. నౌ వాట్ ఆల్ యూ హావ్ టు డూ ఇస్ ఇంటిగ్రేట్ దిస్ ఫంక్షన్. ఎలా ఇంటిగ్రేట్ చేస్తారు? ఎక్స్ డిఎక్స్ రాస్తారు. I integrated from where to where? Let's say at x naught, this is v naught, and x it is v. All right. ఇది సాల్వ్ చేసి రెడీ పెట్టండి. Then we'll plot the phase portrait. As we have plotted the phase portrait for a is equal to minus x, we'll plot the phase portrait for a is equal to plus x. All right.
Yes, sir.
Yes,
So
sir.
all you have to do is today is ఇది v square by 2 రాసి x square by 2 రాసి 2 క్యాన్సిల్ చేసి అప్పర్ లిమిట్ లోవర్ లిమిట్ సబ్స్టిట్యూట్ చేసి x square plus y square or x square minus y square is equal to constant square అని ఏదో వస్తుంది, కాన్స్టెంట్ అని వస్తుంది. x square minus y square is equal to constant అని వస్తుంది, or y square minus x square is equal to constant అని వస్తుంది. All right, get that equation. That's it. That's your homework. All right.
Okay, sir.
All right. So it's doable now. It will take hardly maybe 2 or 3 minutes for you to do this. You think through everything. You write the equations for a is equal to x, a is equal to minus x. You think through again. ఇక్కడ వదిలేస్తే ఏమవుతుంది, అక్కడ వదిలేస్తే ఏమవుతుంది, ఇక్కడ ప్రొజెక్ట్ చేస్తే ఏమవుతుంది, ఎక్కడ వరకు ఆగిపోతుంది, అక్కడ వరకు ఆగుతుంది, ఎందుకు ఆగుతుంది? Because there is a retardation, because velocity is opposite to acceleration. But once it stops, it will come back. All right, and it will overshoot origin. మళ్ళీ ఇక్కడ వచ్చినప్పుడు మళ్ళీ రిటార్డ్ అవుతుంది. In this case, but ikkada it's going on accelerating. It's not retarding here. It's retarding when I project it towards left. So ikkada project cheste ikkada chi agutundi. All these things you do, and it will take hardly 10 minutes. And you write this equation. Be ready for the phase portrait tomorrow. Phase portrait redraw chestam. All right. In the additional class we have got, we'll do some revision. All right, some basic maths or graphical analysis chesdamu. All right, that will decide. I'll plan and decide. All right. So that's it for now. It's already time. I'm late. Your maths sir is waiting. Gurinder sir is waiting. All right. Thank you all,
Sir,
students. Yes.
Is there any class on tomorrow's afternoon?
We'll let you know in the WhatsApp. Give me some time. I'll discuss with madam.
Sir,
Okay,
in the
sir.
All right. We'll let you know in the WhatsApp.
Sir, in the morning section,
Sorry.
is there any class section, sir?
In the morning you'll have as usual class. 5 to 7 is.
Okay, sir.
All right. Morning session is as usual. Evening session is as usual. But we may have an extra class in the afternoon.
Yes, sir.
All right. So you're able to follow, students.
Yes, sir.
Yes, sir.
You're able to
Yes.
enjoy things. Are you enjoying physics?
Yes, sir.
Sure.
Yes.
Students, you can compare this with your classes also. All right. I can challenge you that even akkada chepparu. All right. You might have experienced also.
Yes,
Once
sir.
you are going for coaching, you can experience there. Even cheptunnaru akkada.
No, sir.
Okay. No, I mean, I'm sure about it. All right. Because I know, now, see, this is taught only for the top batches. Top sections untai kada, top rankers ke. Like Hyderabad, you have got one section. Only one section is there in Hyderabad for top batches. వాళ్ళకి చెప్తారు. So Delhi also, Kota also, there is some top sections. అక్కడే చెప్తారు. So this is taught only for top batches. You're also a top batch from super 20, super 100 నుంచి వచ్చారు మీరు. That's why all these things are being taught for you specifically. ఇదే నార్మల్ క్లాస్ వెళ్ళి వేరే batches కి చెప్పారు. All right.
Okay, sir.
Okay.
All right. So make
Okay,
use of it.
sir.
Okay, sir.
Chalo, bye then. Bye. Good night.
Bye.
Bye,
Thank you, sir.
Bye. Good night, sir.
Bye. Bye. Thank you.
Yes, sir. Thank you, sir. Sir, you can start the next class, sir.
All right, ma'am. All right.
Yes, sir.